Good morning on a Thursday. I am here again. It's Magnus, and I'm doing interviews again for Ignite. This time I have been able to sit down with Martin Woodward, who is a program manager for the Visual Studio Team Services team, and we're going to talk about actually the things he was presenting at his very, very interesting session about an Azure migration you might have heard of.
Hey Magnus, how you doing?
I'm all right, and so you had a good session, I hear, and it was apparently quite well received, so yeah. Good on you. and it was about the migration that you did from moving team services to the cloud.
Yeah, so we for years we've had the on-premises product Team Foundation Server, which is provides source control, Git as well as TFEC, work item tracking, builds, release management, all that sort of thing. We've had that as an on-premises product for years, and then around about 2010 we started the transition to move it from an on-premises product to a cloud-based solution. Yeah. And what's quite interesting with this is that it's actually a single piece of software that we build, we ship in the cloud first, and then we package up roughly every quarter, package it up in an ISO image, and then ship it to our on-premises customer store, because there's still lots of people who aren't quite ready to move their source code into the cloud yet, but so we still ship an on-premises product for them. Okay. And the talk I gave was about moving 65,000 Microsofties to DevOps in Azure, because basically VSTS, so Visual Studio Team Services, is not just where we give you Team Foundation Server to use with your teams, it's what we also use inside Microsoft to build our products now. So we use it to build VSTS, as you would expect.
It's like Inception, right?
Exactly. Well, no, it gets worse. So we use VSTS to build VSTS, but we also use VSTS to build Azure.
Oh, right.
And then we use VSTS to build Windows as well as Office and things.
Obviously
so
very, very critical.
Exactly, mission critical software, not just to us, but obviously to all of our customers.
Yeah.
And so now the talk was it was an unusual one for me, because I'm used to doing demos, and I love technology, getting really excited about the technology part.
Yeah.
The technology of this, like the cloud stuff's cloud stuff, and it's actually fairly straightforward. It's doable. It's achievable. It's not, it's computer science, but it's not rocket science. You know what I mean?
Yeah.
The hardest part of this transition for us as a team was learning how to work as a true DevOps team, because we'd gone from shipping on-premises product where mean time between failures is very, very important, because once you put things onto a DVD, it costs a lot of money to bring those back and shred them and things like that. Whereas with the cloud, it's all about mean time to release. How quickly can we get a new version out? And we've gone from shipping every 2 years in the on-premises product kind of thing to the where we are now, where we ship multiple times per day, and then big releases every 3 weeks, because we do 3-week sprints in the teams. But we would regularly send out fixes into production during the day and things like that as well. So there's 2 trains that go a day, and then every 3 weeks is a big train as well.
Wow, yeah, that's pretty impressive, and again, on a scale which is probably unprecedented for most other people. So you're saying that you're basically, if I understood you correctly, you're basically shipping the same thing to customers that you are putting on the cloud.
Yeah, it's the same code base, and there's some if statements in there that are like if in cloud, So the main differences between the on-premises and the cloud-hosted product are actually in the release management phase, which we'll talk about in a sec. But in the code base, it's things like if TFS, then when you talk to it with your Git server, send the TFS ASCII art back. If VSTS, send the VSTS ASCII art back. When you're talking to when we're doing data storage on premises, disks are disks. Yeah, so we store everything in the SQL database in the on-premises product, because it's just a hard drive. Hard drives have the same price. Yeah. And there's a lot of good things by doing that, because it means when you take a backup of your database, you've taken a consistent backup of your source code, your work items, your builds, everything gets back to in one go. In the cloud, SQL relational data is expensive, but blob storage is very, very, very cheap. So what we did is we've got an abstraction layer at that point where we any relational data we store in SQL Azure, but then we also store the binary data into blob storage, and so there's a few if statements, but it's the same code base.
That's very interesting, because I've done the same type of work, and it's the case of having to, for business reasons, having to ship 2 things. And in so doing, you must become very, very organized and very streamlined to be able to split that up, to be able to ship two things. One is a product, the other one is a service, essentially.
Yeah, and it does influence your architecture choices.
It does.
Because if we were pure cloud, then we would probably use a lot more PaaS. We'd be very big into a lot of the Azure functions and all of the serverless stuff, because we have things that happen synchronously, to serve your request. But a large part of the workload we have asynchronous, because that's how you get performance. Yeah. So in the on-premises product, you'll see like you obviously see the IIS application, but you also see a couple of Windows services, and those Windows services are the ones that are running the background tasks that then do scheduled things. We call those job agents, because they're basically running jobs. But they could really easily be Azure functions.
Of course, yeah.
But we can't do that because we're trying to ship the same product, Now, when Azure Stack comes along, maybe, but there's so many people that want to take our software and install it on an ISO image, and have an MSI, so we need to do it. Yeah. So we end up doing things like, at the minute there's a lot of IaaS in there, so we do have quite a few VMs and things, but we also have, we're moving increasingly to sort of containerizing a bunch of our services, and that makes it, and so, but the containers are the deployment package for the cloud, not for the on-prem. So for on-prem, it's still an MSI file. Right. So it's at the release phase where we fork off and we decide, do I want to build an ISO image, or do I want to massively deploy to 15 data centers across, and even that deployment's really interesting because, we're in, let's say, 15 data centers, I think now, and we, keep adding new ones. So we have to do things like we have to be able to do, we have to be able to scale up a data center in a script. Yeah. We have to be able to, create a data center in a script. We have to be able to just move things around and kind of split things out a bit more so we get cross data center resiliency. Okay. In there is a service in VSTS called TFS, confusingly, because that's how it began. It began because it was all in one monolithic code base, because it was an on-premises product. We had this TFS as one service, and that's where currently today the Git functions are hosted, work item tracking functions and build, the core functions are kind of hosted in there. We did pull that apart, ripped it. We're slowly decomposing it all, but we did a major sort of pull apart because we needed the account services and some core common shared platform services to be separate from the main TFS services to have resiliency and redundancy. So we did that kind of tearing in half, which was very painful because when you try and decouple a code base like that, it's hard. And then new services now we're building as standalone services, and then they're obviously, and then we've currently only got about 3. We're on about 3 at the minute that are actual true containers. 3 that are services that are containers, and then our Linux build hosts. Because when you use VSTS to build your products, you get a hosted build server. You can do a Windows build or you can do a Linux build, and the Linux build is just a Docker container running our Linux build image, and then so that's super fast for us to spin up and tear down again. Much faster. Whereas on the Windows side, we have a whole bunch of VMs provisioned ready for you to do your builds.
Your own custom ones.
And it's our own custom image that we've got defined, but it's got like Visual Studio 2017 installed in 2015, the latest versions of the .NET framework, latest versions of .NET Core. It's got Maven installed in there, it's got Java installed on there, and it's got all the the Google Play tools and things, because we deploy to everything. It's not just it's not just Windows, it's not just .NET. So we've got those images that set up as a build image, and what we do is on the build side, we have a pool of VMs ready to go. We give you a VM to run as your build, you run it, and then because, to make sure we get the isolation right, what we do is we then take that, once you've finished your build, we take that VM away, destroy it and provision a new one. Well, actually we start provisioning a new one as soon as we allocate it into the pool, because it takes time. But there's a lot of CPU activity that has to happen, a lot of disk I/O that has to happen to provision new machines and things, and we're constantly trying to reduce. Running a cloud service, you're always trying to reduce your cost of running, and so we monitor our what we call it our COGS, cost of goods sold. So we're always trying to reduce our COGS and provide a better service with lower COGS is always a goal.
Well, that's very, very interesting. Every part of that is very interesting. So did you then give a talk on this, like a full session on this very topic?
Yeah, so I talked an hour on this, and funnily enough, the bits that we've been talking about now, because of the stuff that you're interested in, is more the technology side. I did cover that, but actually doing a transition from a team that was shipping waterfall products to because that's shipping every 2 years with a very hard deadline, with a thing that you can't change afterwards.
Can never be wrong.
That is the definition of that. Like, it's easy to fall into waterfall in that scenario.
Definitely.
So we went from there going through Agile into DevOps, where we're now a full DevOps team, where we have dev. We got rid of the notion of dev and test. They're now engineers.
Okay.
We have the SREs, so the ops people are also in the feature team embedded, and we have a feature team. The key difference is we have the feature team owns the delivery of the feature to the customer.
Yes.
So our definition of done, when you're not done with your feature until it's running in production, it's collecting telemetry that then verifies the hypotheses that originally motivated the development. So it's more of a build, measure, learn, hypothesis-driven development type thing, and that's where we are now. Is actually running in production. We didn't get there straight away. When we started doing Agile, it was potentially shippable, and then it went from potentially shippable to shipped, and now it's potentially shippable, shipped, collecting telemetry that then validates your hypothesis. So that and DevOps isn't a destination. DevOps is a journey where and the whole point is we're continually trying to improve, continually trying to learn in a very iterative way and get better at how we ship software, so we can deliver the flow of value to our customers.
Yeah, that makes a lot of sense. So the in the beginning, chaotic, painful, and you have come to a place where you're actually shipping this thing, as you said. You do a release of some sort every 3 weeks, every sprint.
Yeah, a big release every 3 weeks, and then we do releases twice a day normally, or we can do emergency fixes whenever we need to. But a normal release is about every 3 weeks, and it's because we're 15 data centers. We have some good advantages to our side, because we use the software ourselves in the team to build VSTS, but also because we use VSTS to build other parts of Microsoft. We do a staged deployment, so we roll out to ourselves first. So we have 5 rings of deployment for these 15 data centers. The first ring is us, and so we get our pain first. If we break something, we're the first people to know, hopefully. And we're fairly active, so we put a good load through, but there's nothing that can really test, production load. So then we then migrate it out to the next data center, which is our smallest data center. We then take it to our largest data center. Then we take it to our international data centers, because there's a high latency, and then we take it to everybody else. And that we do this stage deployment across all these data centers, so we can stop the deployment if something's going wrong. We can stop the train.
So so that means that TFS, the Visual Studio Team Services, the service that everybody uses, is in fact hosted in the Azure data center.
Oh yeah. Cool. It's all using Azure, and we use most Azure services. So we're not using Azure Functions much yet, but we do. But we're doing, but we've got like Azure Key Vault. We've got, we use most of the stuff, and more importantly, we are the DevOps platform for Azure. We are the dev tools for Azure. So every Azure thing you want to deploy, we need to be able to deploy to it. And actually, it's not just Azure ones. We Amazon provide the AWS publishing tasks for VSTS. Google have ones for GCP. So and we also are able to ship on-prem. So it's you're able to build your own software and deploy it anywhere using VSTS and deploy to the cloud or on-prem. Or you can use TFS, which is the same product, just a little bit behind the cloud.
That's right.
To ship to the cloud or on-prem, you know what I mean? So that's the advantage.
Incredibly interesting, because you have to have all these relationships with all of these, well, to be quite frank, competitors as well, to be able to talk nicely with them and bake that into the whole story.
And that was actually one of the reasons. So we have a really, really good extensibility model in VSTS, and it's incredibly rich. And it's one of these cases where the internal, we call it dog fooding in Microsoft, which is a horrible term. Drinking your own champagne is a term that
I like that better.
Yeah, that's more European.
Very
but
much.
no, dog food. I hate dog food.
Yeah, what do I?
Anyway,
I hate dog food.
Exactly. But because we're doing that, when you're trying to roll out, when you're trying to convert a team the size of Windows with as smarter people as Windows has working for them, they have demands for how they want to run their engineering system, and we have our priorities to how we want to run. We've got to run an engineering system for everybody, not just people in Microsoft.
True. So even if Microsoft is super powerful and super important, we still have very many other customers.
Exactly,
and
so it doesn't always get to the top of our backlog, and nor should it, because we've got to serve our customers.
I would agree.
And so what we did instead was we invested in our extensibility model and gave a very, very, very rich extensibility model. Because then we can say to the Windows team, hey, there's two ways that we can collaborate with the Windows team. Hey, here, extend VSTS yourself, go do some stuff. Or what we also do is what's called inner source. So within our engineering teams in Microsoft now, because we're all on VSTS, we have it so that everybody can read everybody else's source code, but you can't write. So it's permissive read, restricted write. And then we use open source style workflow, so inner source, inside the enterprise. So if I wanted to, I could send a pull request over to the Windows team to add Windows line ending support. No, Unix line ending support to Notepad, for example. I've tried. It's actually really, really hard. But you can do those types of pull requests between orgs.
So it's
but
possible.
also we have the extensibility model. And because we have this rich extensibility model, it means that other people can plug in. And you can plug anything. You can plug in games. You can plug in really deep into the UI, not just tasks and things.
So you're getting suggestions from the other teams?
Oh, yeah. I mean, they have suggestions, and sometimes we build them. And quite often they'll build them for themselves and then make them publicly available. But it also with our partner community as well. We've got an amazing community of MVPs and partners who build extensions for VSTS, and then we have competitors who are like, well, we want to be in that tool. And we're open nowadays. We integrate with all open source and everything else, and we're completely open APIs.
Right.
In fact, our extensions are all open sourced on GitHub. The ones that we ship in product are all open source, so they can look at our build tasks and see how they're built, and then use those, and they can then decide if they want to ship their own or if they want to send a pull request to us to ship it in box. So I know.
I think we could talk about this all day.
Exactly.
Honestly. It is very, very
watch
interesting.
the talk.
Watch the talk, and at some point I'll probably come back to you and talk more about this, because it's hyper interesting. And honestly, I would say there are so many companies out there that are on your journey or are about to begin or are in the middle of it. I honestly think there are a lot of people that should check out your talk. I'll be sure to put a show note for that, and I'll put this video up for you. But thank you for taking the time to talk to me. I really appreciate it.
You're very welcome.